Hello everyone and welcome to another VASaviation video. In this VASaviation lesson we will go over the two main compass errors and we'll learn how to deal with them when flying our aircraft. Some days ago I posted a question on Twitter asking about the relation between the aircraft compass and a particular turn. The compass is an instrument based on magnetic forces and due to its building and structure doesn't always tell us the truth. In this lesson we'll learn how the compass works, the theory of these errors, and we'll try to visualize it using a flight simulator. Be advised, this video will be explained as if we are flying in the northern hemisphere and at a medium latitude. The southern hemisphere would work opposite. These two errors are usually called turning error and acceleration error. If we happen to be on a northerly or southerly heading and we initiate a turn one side or another, the compass will not show the entire truth. If we happen to be on an easterly or westerly heading and we accelerate or decelerate, the compass will show a variation that is actually not the truth. We'll take a look at these errors one by one, learning the theory. I will also tell you mnemonics to easily memorize, and then we'll try to see it in the flight simulator. To understand both, it's important for you to understand the magnetic dip or magnetic inclination. This is the angle that the needle makes with the horizontal plane of the Earth's magnetic lines. The magnet of the compass is constantly seeking to align with these magnetic lines. These magnetic field lines are not parallel to the surface of the Earth, so the magnet of the compass will dip downward in the northern hemisphere, called a positive dip, and upward in the southern hemisphere, negative dip. This dip, therefore the resulting error, is 0 degrees over the equator and 90 degrees over the poles. This means these errors don't exist flying over the equator, and the closer to the poles we fly, the more the errors increment. We'll also consider that because of a turn or a speed change, the aircraft, therefore the compass, suffers different forces such as inertia, friction, or even gravity that affect their behavior. We'll start talking about the acceleration error. This error only appears when we're flying on headings east or west. If we happen to accelerate the airplane, the compass will show a turn toward the north and then progressively return to its original correct indication. If we decelerate, the aircraft will show a turn to the south and then progressively return to its position. If we accelerate or decelerate while flying north, south, or any heading other than east or west, the compass will just move or tilt because of physical forces projected onto the pivot, but will not indicate different than the current heading. The acceleration error only shows up on east and west headings. A good mnemonic to remember this error is the ANDS, A-N-D-S, which stands for accelerate north, decelerate south. Remember, this is applicable flying in the northern hemisphere. A good mnemonic for southern hemisphere is SAND, S-A-N-D, which stands for south accelerates, north decelerates. The turning error is a little trickier, and we'll take it slowly for a good understanding. In medium latitudes between 35 and 45 degrees, the maximum of this error is about 30 degrees. There are some formulas and rules of thumb that we'll talk about later. The turning error VASaviation theory tells that the compass lags in northern headings and leads in southern headings. Imagine we're flying heading 360, heading north, and initiate a turn to the right. The compass will immediately indicate a turn to the opposite direction as if we were turning left. As we continue turning right to the east, the compass will progressively reach a real heading so that the error is 0 at the time we face east. The compass has lagged behind, indicated less than the real heading, between headings of 360 and 090. In case of a left turn, the compass would have lagged, indicating more than real. Once we pass east or west and continue heading south, now we are in southern headings, the opposite happens. The compass will not lag behind, but lead ahead a real current heading. The error now will progressively increase from 0, remember the error is 0 degrees on east or west headings, to its maximum value when reaching southerly heading. The compass is now overreading. It is indicating more than real. In case of a left turn coming from west to south, the compass will be now ahead of a real heading, indicating less. It is under-reading. The usual mnemonic for this error is called a UNOS, U-N-O-S, which stands for undershoot north, overshoot south. This is very important for a pilot to know in order to complete turns and establish the desired headings correctly. Following the example above of the right turn, if we'd like to establish a heading of 180, we know the compass is giving us a fake indication, so we must deal with it and battle for a correct rollout. We know the compass is overreading the real heading, so in medium latitudes, as mentioned above, we let the compass pass by 30 degrees, overshoot, should read 210, and we will roll out. When wings are leveled, we should be on a southerly heading, and the compass will slowly move to the original correct position. The opposite happens if we want to establish a heading of 360. Remember that the compass lags behind real heading. If we are turning right, we should roll out 30 degrees prior the desired northerly heading, undershoot. When the compass indicates 330, we level the wings and we should be established on a 360 heading. As I said, there are some formulas to discover how much error my compass suffers in the area I'm flying. One of the most common formulas is the 15 plus half of the latitude. For example, for a latitude of 40 degrees, the error would be 35 degrees. This is the maximum value of the error shown when on northerly or southerly headings and is diminished as we fly toward the east or the west. Another formula commonly used is 1/3 of the bank angle plus half of latitude. For example, for a latitude of 40 degrees and a 30-degree bank angle, the maximum value of the error would be 30 degrees. A rule of thumb states that the error decreases by thirds as we get closer to east or west. This means, at a latitude of 40 degrees, that if the maximum value of the error is 30 degrees, the error would be 20 degrees on headings of 030, 150, 210, and 330, and 10 degrees of error on headings of 060, 120, 240, and 300. This indicates a progressive error between north-south when the error is maximum and east-west when the error is 0. We finished the lesson about the turning error and acceleration error of the compass. Other errors like deviation, oscillation, or variation also affect the compass and will be learned on a future lesson. I really hope you enjoyed the content and learned new things about the aviation world. If you have also any questions related to this lesson or any other topic, don't hesitate and leave it right below on the comment section. It's VASaviation, frequency change approved, and see you guys.